Hello. In this lecture, we'll be continuing CPU scheduling and we'll be looking at threads and how to use threads and what are the advantages of threads compared to processes. Reading for this lecture would be chapter 5 of Dinosaur Book or chapter 7, 8, 9 of Comet Book. So in the last class, we looked into various scheduling policies, specifically FIFO, round robin, and shortest job first. And we saw that each of these scheduling policies have various advantages. However, ideally, we want a scheduling policy that can give something of everything, right? So we don't want to maximize just one aspect. We want to optimize on all the aspects, right? We want to have good response time, we want to have good throughput, similarly good turnaround time, and also scheduling policy should be fair. So can we have a scheduling policy that has everything? So in that direction, if you think about it, priority scheduling is one policy that can actually could give everything. Okay, so here the method is pretty simple. So for each process, we assign a priority, and while scheduling, we just pick the process with the highest priority and then schedule it. However, if there are multiple processes with the same priority, we use first in, first out. And then we can actually adjust the priority on demand, right? Like we can have a process with priority, with high priority, and then as we continue the execution, the process we may change the priority later. So, and here one important aspect is setting the priority. So who sets the priority? So priority can be either set by operating system or it can be set by the users. So operating system can set the priority of a process either by looking at its behavior. For instance, it can see that if the process is using a lot of IO, then it can decrease the priority. Similarly, if the process is using a lot of memory, it can decrease the priority. And if a process has strict time constraints, maybe it can increase the priority. So operating system can do this. Similarly, users can also change the priority, right? So depending on the importance of the process that user uh, is interested in, and also maybe some user pays to the system administrator so that his or her jobs get higher priority. So the decisions of increasing the priority could be different. However, dynamically adjusting the priority is still tricky because there can be various reasons why we want to change the priority. But when to change the priority and which policy is good, it's still tricky. So we know priority scheduling is amazing because it has something of everything. It provides decent uh, performance goals. However, it has one big disadvantage: starvation. Basically, a low priority process might never get to run, because imagine if there are several high priority processes that are coming into the system, then a low priority process might never get a chance to run, so it will just get starved. Okay, so there are multiple ways in which we can do priority scheduling. So one simple way is multiple queue scheduling. So here the approach is simple. So we maintain different queues based on priorities. So for instance, we can have a background queue of low priority, and we can have queue which is foreground queue that has higher priority. Okay. And of course, while scheduling, we prefer the jobs in higher priority queues. So this is an example of multiple queue scheduling. So here, as you can see, we have different queues and each queue has various processes. And Q1 is low priority and Q8 is a queue with higher priority, highest priority. So there are three fundamental challenges in multiple queue scheduling. The first challenge is how to assign processes to the queue, basically how to determine the priority of a process. Okay. Second one is how to schedule processes within a queue. Now that we know we have different queues, we need to understand how to schedule processes within each queue. And now we have multiple queues. We should also know when to switch between different queues. So, so we should know how to assign priorities to the processes and how to schedule processes within a queue and how to switch between the queues. So these are the three main challenges in multiple queue scheduling. So how to assign process priority to the processes, or like how to assign processes to different queues. So this again could be based on user, as I mentioned. So system admin processes that are created by system administrator could be put into higher priority queues, whereas regular user processes could be put into low priority queues. And it could also be based on types, right? If a process is a UI process, which for instance Chrome like browser, which is very UI intensive, it could be put into higher priority queue like foreground queue. Similarly, when you have some computation job that is doing some machine learning training, that could be put in the background queue. So we can assign process to the queue either based on user or based on the type. Now, how to schedule processes within a queue? This is the second challenge. So in the simplest case, we can just have a same scheduling policy for every queue, right? Like we have, let's say we have different queues. We can either use first come first serve or round robin. We just pick one scheduling policy and use the same scheduling policy across all the queues. An interesting variation of that could be to use different scheduling policy for different queues. For instance, we know that foreground processes need to be responsive, right? So we can use round robin scheduler for foreground queue, whereas for background processes, we want quick turnaround time. So for that, we can use shortest job first. So there are two approaches, right? So we can either have fixed scheduling policy for all the queues, or we can change the scheduling policy based on the queue types. So and finally, the last challenge is how to switch between queues. So we can again there are two obvious approaches. We can have a fixed priority where uh, each queue has fixed priorities. So the lowest priority queue only gets to run when there are no processes in the higher priority queues. Okay, so like there is no scheduling between the queues. Like the lowest priority queue gets a chance only if there are no processes in the higher priority queues. That's one approach. The second approach is we can have time slice between the queues themselves. Like we can give certain time to queue1, like first queue, and then maybe some other time, like another chunk of time to queue2, so on and so forth. We can do scheduling between the queues as well based on time slices. So what are the advantages of multiple queue scheduling? So it has very low overhead, right? So once we uh, assign priorities to the processes and then put them into the queue, that's it. We don't need to do anything. The scheduling of the jobs happen based on the policy that we selected. Everything is nice. And one thing to note here is jobs don't move across the queues. So once the job is assigned to a queue, it just stays in that queue for its lifetime. And there is no overhead because jobs don't move. And what are the disadvantages? So the same thing, uh, since we cannot move jobs across the queue, this actually is inflexible. It's not flexible because programs may change. The behavior of programs may change. For instance, a program may be CPU intensive for some time, and then maybe suddenly it can become IO intensive. So we may have to change the process. We may have to uh, move the process into different queues. But however, in multiple queue scheduling, it's not possible. And we need to also need to have some learning to do the to move the processes between the queues. However, there is no learning in multiple queue scheduling. So once we assign a process to the queue, that's it. We are kind of stuck to it. And this again, depending on how we switch between queues, there can be starvation, right? Like imagine if we have a fixed priority queues, then the process in the lowest priority queue might never get to run if there are some processes in the higher priority queues. So the fundamental problem, or rather disadvantage in multiple queue scheduling is fixed priority. So once we assign priority to a process, we can never change. So that seems to be the fundamental problem. So multi-level feedback queue scheduling policy tries to fix it. So the way it works is jobs always start with highest priority queue. So whenever a process starts, it always gets the highest priority. Okay. And there are three things that can happen to the priority of the process. Priority might decrease, priority can change, can stay the same, or priority might increase. Okay. So priority decreases when job uses the entire time slice while running, then the priority is decreased. Okay. So priority remains unchanged if the job or like if the process gives up the CPU within the time slice. Okay. So let's say we are using round robin scheduling. So when we schedule a job or process, if the process used the entire time slice, then we decrease the priority of the process. Whereas if the process gives up the CPU before the time slice, then the priority remains unchanged. Okay. And we actually increase the priority of a process when we see that like when we see that there are jobs that are waiting for a long time. If there are like long running jobs that are moved to the lowest priority queue, then at certain intervals we can move those processes to the highest priority queue. Okay, this is how the priority of processes increases. Okay, so three things: priority decreases when the process uses the entire time slice, priority decreases when the process gives up the CPU within the time slice, then priority stays the same. And at regular intervals, we increase the priority of the lowest queue, or like increase the priority of the processes which are at the lowest priority queue and we promote them to the highest priority to avoid starvation. Okay, this process is also called aging. So when the process ages, or like when it is in the system for a long time, we actually automatically increase the priority of that process. Okay. Let's look at few examples. So C is the single long running job. So here, as we have seen, C always starts with highest priority. So Q2 is the highest priority queue. So C always starts with the highest priority. And since C takes long time, so after time slice 1, it moves to Q1. So after time slice 2, it moves to Q0. Okay, and it stays in Q0 for its entire life. Now consider a case where we have C. However, we also have smaller jobs like A and B. Okay, so C moved to the Q0 after 3 time slices. And now let's say job A comes in. So since every job starts with the highest priority, job A will be in Q2. So we start, since Q2 is the highest priority queue, we start picking A and we start executing A. A finishes within 1 time slice. So that's all good. And then C starts running because C is the only job in the system. And then B gets submitted. So since all the processes start at the highest priority queue, so B starts running. However, after the first time slice, B gets demoted to Q1. but B finishes in second time slice. So B is done. Now C continues. Okay. However, as you can see, there is a potential starvation here because this C, if it is really long running process, then all the new processes might consume the CPU with C never getting a chance to run. Okay. So in order to avoid this, we do the we increase the priority as I mentioned before. So this is usually done by using boost time. So what it means is at regular intervals, we actually move the process from the lowest priority queue to the highest priority queue. Okay. So let's say the vertical lines are the boost times. These are the times at which processes that are in the lowest priority queue will be moved to the highest priority queue. Okay. So here in this, when at the first boost time, since C was in Q0, lowest priority queue, we moved it to Q2, which is the highest priority queue. Okay. So C gets to execute because it's in Q2, and then the same thing happens. C gets demoted after each time slice, and then after again at the next boost time, if C was still running, it will be again moved to Q2. So this nicely prevents starvation, right? Because if there is a long running job, we kind of give it a chance to finish by moving it to the highest priority at regular intervals. Okay, this is a state of art for with respect to scheduling policies used in different operating systems. So initially, like old times when we have Windows 3.1, those are the first user operating systems that came in. So we used cooperative scheduler, where it's basically a non-preemptive scheduler, where the processes are cooperative. Processes voluntarily give up the CPU. Those are the good times. But as the internet opened up, as we started to run processes from different people around the world, when the security became really important, uh, then the problems of starvation became more severe. So that's when we went into multi-level feedback queue scheduling, and actually multi-level feedback queue is actually one of the most popular scheduling policy. It's actually used in most of the operating systems now. However, Linux now uses a scheduling policy called completely fair scheduler, that is based on the execution time. Here they use a red black tree to store, instead of using a queue to store processes, they use red black tree to store process control blocks. And the red black tree is ordered by execution time. That way they try to uh, they balance between responsiveness and turnaround time in a nice way. Okay, and we'll look into threads in the next part of the lecture. Thank you.